And we're back. This time talking about higher derivatives, which is going to be an extremely simple, short, direct topic. If we wanted to say that we were taking the second derivative, right, we can write 2 tick marks for double prime, second derivative, third derivative, be f triple prime of x. Process stays the same, which just means things can get tedious, especially if we have some gnarly rational function. But let's keep it the same, and let's say that we're supposed to calculate f triple prime x of this very mundane polynomial f prime of x. Right, we're going to use power rule across the board here. So 15x to the fourth, because 5 times 3 is 15, subtract 1 minus 4x plus, oops, that should be a minus. Just making sure you cats are awake. Okay. And since you're at home, maybe quick pause, see if you can calculate the rest of them, and then press resume once you have done so. 60x cubed minus 4 plus 42x to the negative fourth, which leaves us with a third derivative of 180x squared. Since minus 4 is a constant, it disappears. And minus 168x to the negative fifth. Alright, well, that's the process, but what is the purpose of higher derivative, right? Since we know that the first derivative tells us the rate of change, so what roles do the second derivative play? So the second derivative is actually really crucial and is going to be a focal point of our discussion on curve sketching, which is the next chapter. But this is the rate at which the first derivative is changing. So graphically speaking, f double prime measures how fast the tangent lines change direction and which is the bending or concavity of the graph. Definitely said it earlier in a previous video, but this is the purpose of calculus. It takes that initial foray into curve sketching that we discussed in Algebra 2, where we were just focused on essentially the x-intercepts, the y-intercept, and the end behavior, where we got through pre-calculus, which started to introduce, specific point values for the maximum minimum, and now we have fully fledged graphs that we can draw based on these calculus applications. For those of you taking physics, remember S of t represents position of an object at time t. S prime of t is the velocity. S double prime of t is the acceleration. And I teach mathematics, so I have no idea what an application problem looks like for the third derivative, but I do know that represents the jerk. So, on that note, I'm going to conclude this video. So maybe your beak has been wet, and you get lost in a sea of Google trying to find out what that actually is. Have fun.